So in this unit, we're going to be dealing with inequalities. Let's look over here and see our couple of learning goals that we have today. Danny, will you read the first one, please? Inequalities. Okay. Okay, well she read them both for me so that she could practice saying inequalities, right? Equality is when there's what kind of a sign? Equality would be what kind of a sign in the statement? An equal sign. And inequality means that we cannot set one side of the statement equal to the other. We have to compare them in a different way. So today we have to be able to analyze what inequality should we use and what would the graph look like? In other words, how could we show what that means? So here's my first one that I just showed, an equality, x equals 5. If x equals 5, that is saying 5 is the only value that x can be for whatever the situation is. So then we just have a closed, a shaded in circle at 5 on the number line showing 5 is the solution, okay? When we have inequalities, there are actually 5 possibilities of ways we can show the relationship. So this first symbol there that we have right here is pointing, it's like a V on its side pointing to the right. Anyone know what that stands for? What does that mathematical symbol stand for? Wait?
Less than? Or no, greater than.
Okay, but we're going to add the word is greater than. Okay, so let's write is greater than. Because we have to be really careful. Greater than really means addition. But as soon as we say is greater than, now we're showing that we're making a comparison. We are not doing addition. Okay? Well, what happens when they have that same symbol and they include this little dash, this little line below it? What does that do to it? How does it change it? Cheyenne?
Is greater than or equal to.
Yeah, now we're talking about is greater than. That takes care of the V on its side. Or is important that we say it, or equal to, because it doesn't have to meet both standards. There's no way you will find a number anywhere on the number line that is both greater than and equal to another number. It can't be both. So it's one or the other. Now, if you do not know these yet, for whatever reason you're not familiar enough with them yet, you need to make sure that you figure out a way to learn them and keep them. You need to know these inequality symbols just as well as soon as you see an equal sign, you don't have any hesitation at all what that says, do you? You just look at it, you say is equal to. We should be able to do the same thing with these inequality symbols. Okay, what do you think this next one is where the V is on its side, but now it's pointing a different direction? Paikia? Is less than. Okay, and we want to make sure we use the word is because less than can indicate subtraction. So is less than means we're making a comparison. Okay, how about the next one then? What were the next ones? How would that one read? Harley?
Is less than.
Maybe you can't see it here, but there's a little line underneath it. So what does that little line do to it? Caden?
Is less than or equal to.
Or equal to. It includes the other condition. It can be equal to. So it has one or the other condition that it is making the comparison with. And then our last one, which we don't use a whole lot, but we need to make sure we know that it's part of the inequality symbol thing. Sylvia, do you know what that one is? Oh, the equal sign with a line through it. Anyone know what that is? Cheyenne? Is not equal to, yeah. That just is saying, instead of saying is equal to, that line says no, not equal to. Is not equal to. Okay. So these are our 5 inequality symbols. And instead of us being able to say there's just one value, we're going to have to make a comparison instead, because sometimes our variable has to represent a group of values. So when a variable has to let's underline this. When a variable can represent a group of values, there's more than one, not just 5, not just -2, but a group of values, that's when we need to write it as an inequality. When it needs to represent a group of values, we write it as an inequality. So some of what you're going to be doing today, they're expecting you to be able to do, is take an algebraic statement. It has a variable in it, it has an inequality statement in it, it has a constant in it, and you have to write what that means in words. So what is it telling us? So that first one, how would we describe this inequality right here, right? This one. How would we describe that? What does that mean? Wade?
X is less than or equal to 7.
Yeah. X is less than or equal to 7. So 7 is part of the group, and any number smaller than 7 is part of the group. When we graph these, on your worksheets you will see more detailed number lines than I'm going to make you create when you have to create your own number lines, okay? Here's what I have you do. So listen carefully so that you understand what I expect of you, okay? Because can we begin to show the whole number line? What do you think? Why not? Why can't we show the whole number line? Because it never stops in either direction, right? So it goes forever in the negative direction to infinity. It goes in the positive direction to infinity. And we sometimes feel like 0 is right in the middle. Well, maybe sometimes it is, but maybe sometimes it's not. So what we have to do is we have to show a snapshot of the number line. We can only show a portion of it, and then we just show with arrows that it goes on forever and ever in both directions. So we're going to zero in on a snapshot, a portion of the number line when we're showing our graphs. So in our graph, here's what we're going to do. We're going to put a tick mark and we're going to label our endpoint, we call that, that's 7. So right now all we're doing is showing what part of the number line we're talking about. And here's how I have you do graphs. I want to see an integer neighbor on the right, the most immediate integer neighbor to 7. What is the most immediate integer neighbor to 7? Class?
6.
To the right.
8.
8. And the most immediate integer neighbor to the left? 6. So one smaller, one greater. Okay? Because 7 is an integer. So all we have to do is add 1, subtract 1. That's just saying, okay, here's the part of the number line that we're going to talk about. Now what we do is we say, since it says or equal to 7, 7 is included, so we shade in a circle at 7. Make sure I can tell that it's a shaded in circle, and so can you. And then we need to represent all of the numbers that are less than 7. So which direction should we shade the number line? To the left or to the right?
Left.
To the left, because as you head to the left of 7, the numbers get smaller. Okay, so make a nice shading, including shading the arrow at the end, because there's a whole bunch of numbers going on forever in that direction that are included in this group. So basically what's happening is whatever we shade on the number line is representing x. So x can be 7, x can be any number smaller than 7. So give me an example of a number smaller than 7 that should make this inequality true. Danny? 1, okay? So in other words, if we put 1 in for x, 1, would we get 1 is less than or equal to 7? Is that true? 1 is less than or equal to 7. Is it true? Which part of the inequality symbol makes it true? The is less than part, yeah. So whatever number we pick from the shaded region better make the inequality true. So that's just kind of like a check. Okay? If you wrote that down, you might want to put this is a check. Okay. You write out the next one. See what you have. Write down what you think this next one says. Your statement would start out with y. That's our variable this time. Aiden, what do you have? Sam, what do you have?
Y is greater than -2.
Okay. Anyone want to agree with Sam? Give her a thumbs up. Okay. Y is greater than -2. Do we need the or equal to part this time? Why not?
Because it doesn't have the line.
It doesn't have the little line under our is greater than symbol, does it? So we do not include -2 in other words. Okay, so now we're going to graph it. Remember a tick mark in the middle showing where on the number line are we zeroing in on. Integer neighbors on either side. So by the way, when you're making these, since this is an integer, the integer neighbor to the right should be equal distance away from -2 as the integer neighbor to the left. So do your best to try and make them look equally, the distance look the same. Don't be haphazard about it. Okay, not to trick you, but what's the integer neighbor to the left this time? Class?
-3.
-3. -3 is the one to the left. And what's the integer neighbor to the right this time? -1. Oh, be careful because the order kind of flips on the negative side, doesn't it? It doesn't go 1, 2, 3. It goes, oh, -3, 2, 1, -3, -2, -1. Be careful. Okay, we put our circle at our end point. Is -2 a solution? Is it part of the group? What do you think? Is -2 part of the group? Y is greater than -2. Is -2 greater than -2? No. Then it's not part of the group, is it? So we leave the circle open. We say, here's still the end point, but it's not part of our group. It's where we're going to start at. And which side are we going to shade of -2? To the left? To the right?
Left.
Is greater than. So, is -3 greater than -2?
Yes.
No.
No. -1 is greater than -2. That's the neighbor that should be in the shaded region. -1 is greater than -2. So it does get tricky on the negative side of the number line. Okay, let's write out this next one as it says it. And then we're going to talk about how sometimes it's better to rename it than leave it as it is. So what does this say right now in the state that it's in? What does that say? 3 is greater than or equal to what? Z. So instead of starting out with the variable this time, it starts out with the constant this time, the number part. So -3 is greater than or equal to Z. Well, let's just try to graph it before we rename it. See if we can do it. What's the tick mark we want in the middle? 3. Integer neighbor to the left. Integer neighbor to the left. 2. Integer neighbor to the right. 4. Is 3, put a circle there, is 3 part of the group? Is it part of the solution? equal to, what's that tell us to do? Include it, shade it in, include it. -3 gets to be part of the group. Now, which side are we going to shade? 3 is greater than or equal to z. Remember, z represents all of the shaded numbers. Wade, what do you think?
2.
So you want to shade in the direction of 2?
Yes.
Okay. Can you tell us why you want to do that?
Because 3 is greater than 2.
Because 3 is greater than 2. That's pretty good reasoning. So he says he thinks we should shade this way. Anybody want to give him a thumbs up? Anybody want to agree with him that you think we should shade that way? Got a couple of people. 3. Did you hear his reasoning? He says because 2 is in the shaded group, and that means we would put 2 in for z. 3 is greater than 2. So I think he's right, isn't he? So in other words, 3 has to be greater than all the numbers in the group. And that means it's got to be all the numbers to its left. It's bigger than all those guys to the left. Anybody know how we can rename this inequality? Then maybe it would be less confusing for you. Anybody know a different way we can write 3 is greater than or equal to z? Is that a stretch, Hannah, or a handout?
Hand
It's Hannah. Your name's not Hannah.
up. Hand up.
Oh, okay. Okay, Wade, help us out. I want it to start with z, in other words.
2 is less than or equal to 3.
Nope, now you just changed the endpoint. We can't change the endpoint. Ikea?
Z is greater than or equal to 3.
Z is greater than or equal to 3. What do you think, class? 3 is greater than or equal to z is the same as z is greater than or equal to 3. Well, then if that's the case, if this is truly okay, then Wade's 2 from our shaded group, better make it true, is 2 greater than 3? No. What is the relationship of 2 to 3? It's less than. So we need to not make it is greater than, but is less than or equal to. Okay, so let me point out what we just really did, okay? We're going to take this inequality statement right here, and we're going to flip it over. So the z and the 3 are going to trade places, and the sign has to change directions. So this is another way to write that same inequality. 3 is greater than or equal to z. Okay? Questions? Okay, then let's open in your workbooks to page, let's see what page this is. Page 109. Page 109. And I want you to start completing that page for me while I'll turn the lights back on while I am stopping the recording and saving it, and then we'll go through it. Questions?